Hello friends, welcome to Susan and John MacTube. So, after a long time, we are back with a new series in probability and statistics. And from now on, you can expect these videos regularly every Tuesdays and Thursdays. And these videos will be slightly different from the videos that you may have watched before. These will be more or less like our classroom lectures. Anyway, let's start with probability and statistics. So, the first thing, the syllabus. I have divided your syllabus into four parts. If you look at your syllabus, there are 8 units, and I combined them and I have divided it into four parts. So, the first thing we are going to do is we are going to learn the stats, and along with stats, we will learn correlation and regression. In the syllabus, correlation and regression is a 10-mark topic, and normally they ask the remaining stats for 14 marks approximately. And once we cover this, we will jump to probability and probability distributions. That will be another 26 marks. And then something very easy and something very important, that is sampling. That's another 10 marks. And finally, testing of hypothesis. And you have to be aware about one thing. Unlike your mathematics papers, in probability and statistics, they ask a lot of theory questions. For example, in mathematics, they might have asked, what is convergence? Or state Leibniz theorem. Something like that for 1 mark. And you write something casually, you'll get that 1 mark. But in probability and statistics, it's not like that. You can check the past paper questions. They will ask a theory question for 5 marks, sometimes for 3 marks, and sometimes again for 5 marks. And if you analyze the past papers, you'll understand that approximately 30 out of 80 marks will be theory questions. And the remaining will be numericals. But there is no exact ratio that this will be theory and this will be numerical. But you can expect somewhere around 30 marks, and sometimes it will be more than that. So my point is, the theory part should be very, very clear. Okay, now let's go for the first question. What is probability and statistics, and why do you need to learn probability and statistics? Look at this. Not only engineers, but almost everyone in the research field needs probability and statistics. And the good news is, starting from your high school, you have learned a lot of statistics and you have learned a little bit of probability. And the same thing will be used here, but now you have to understand its application. You have already learned a lot of concepts like mean, median, mode, standard deviation, etc., 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 even correlation. We are going to use the same thing, and one more good thing is we can use calculators for the calculation. No need to write tables, etc., etc., like you used to do in class 8, 9, 10. But the most important thing is interpretation. Anyway, let's go back to our original question. What is probability, and why do we need probability and statistics? The answer is very simple: prediction. Of course, we learn probability and statistics for prediction. Engineers need to learn probability. Even medical research people need to learn probability and statistics. Actually, not only learn, they use it. Even the dosage of medicines, when they make medicines, everywhere stats and probability will be used. And powerful social media, and even YouTube is using this probability combined with psychology, and hence making it a very powerful science to find what exactly a person wants to watch next. So The answer is very simple. We need to learn probability and statistics so that we will be able to predict. And before we learn probability and statistics, you should be clear about one thing. That is, it looks like we are living in a pre programmed world. And you might be thinking that the world where we are living is completely random. There is no order. You see many things here and there. But it is not true. There are many patterns going around us, regularly repeating things. And as human beings, what we do is we keep on observing these patterns so that we can imitate them, so that we can control them. I'll give you one example. Just imagine you go to an open place and you throw a ball or a rock or anything, just like this in the picture. And you can see that it follows a parabolic path. And you cannot change it. It's a law of the nature. And this is a very simple pattern, and people observed it, people calculated it, and that is why literally we are in space. We are able to send rockets and do many other things because people learned about the behavior of a projectile. Similarly, I'll give you another example, and that is like really interesting, and I will encourage you to read about this thing. That is called Zipf's law. This tells you take any random book, you take any random book or even a random web page, and then what you do is you arrange the words in the book according to the number of times it repeats. For example, the word the, can you see in this line, the is coming here and it is coming here again. So 2 times, 3 times, maybe 4 times. So I will write the word the repeats 4 times. Like that, what you do is you collect all the words that come in that book and arrange according to the number of time it repeats. Let it be any book in any language, you'll be amazed to see that there is a pattern. And the pattern is 1 divided by n multiplied by the most repeated word. That means if the most repeated word appears 10,000 times, the second most repeated word in that book will come approximately 5,000 times. And the third one will come 1 by third of 10,000, that will be approximately 3,300 times. And this is amazing and this is so weird because imagine you write a book and still there is a pattern in the number of words. Okay, now look at this. The amount of electricity consumed. That is also a pattern. And look at this. When you make popcorn, you might have seen that initially some of the corns will start popping. As soon as you put the flame or if you apply some heat, some of the corns will start popping. Then the rate of popping will increase and increase and increase. And even if you turn off the heat, again a few of them will pop. See, there is a pattern and this pattern is called the normal distribution. So my point is very simple. Before we start probability and statistics, you should be aware that many things in this world follow some sort of pattern. Let it be events which are related to a business, let it be events which are related to certain disease, let it be events which are related to the weather. Many things follow some sort of pattern. And that is why many people believe that someone created this world. Anyway, In my words, I believe that God created it. Some people might think aliens created it, and some people might think some advanced, uh, futuristic people created it. Anyway, that's not important. If you want to learn probability and statistics, you have to be aware of one thing: there are many, many, many patterns around us. And for the last 300, 400 years, what many scientists do is they keep on observing it. And the more they observe, they are able to understand the pattern. And once they understand the pattern, they are able to control the pattern. And once they control the pattern, they'll be able to create new things from that. So, did you get the point? For example, many medicines will be developed through repeated observation. And day by day, they are able to improve the quality of the medicines because they are getting more information. And this information is called data. So, you have to understand one thing: when we start statistics, we need something called information, and more statistically, we call this piece of information as data. And the second thing that we do is we analyze the data. What do? We analyze the data. I'll give you one example. Just imagine there are two shops. One shopkeeper has an experience of running the shop for 1 year, and another shopkeeper for the last 20 years. Now tell me, who will be better in predicting the number of customers that will arrive in one particular day? Will it be the 20-year-old experienced person or the 1-year-old experienced person? I cannot hear you, but I'm sure that you're all trying to tell me it's a 20-year-old experienced person. The reason is very simple. He has more information about the number of customers. He has more information about the number of customers that will come to his shop every day. So, statistics starts with data collection. And second thing is data processing. And once you process the data, that means like what you call, you'll be calculating something which you learned in your younger classes, like mean, median, mode, standard deviation, etc. And once you calculate all these quantities, you'll be able to understand the scenario a little bit better. And finally, implementation. So once more I'll repeat, statistics starts with information collection, that is data collection. Then we analyze the data, that is we calculate some statistical measures, and using the measures we come to some sort of conclusion, and with that conclusion we will move on to implementation. Okay, now when it comes to data collection, you should be aware that some data are freely available. For example, if you go to the hospitals, there will be a record of so many patients, and that information might be freely available if someone is doing research on that particular thing. If you go to the schools, there will be a lot of information about the students, their marks, the attendance, etc. etc. If you go to some factories, there will be an information about the employees, the salary of the employees, the check-in time of the employees. So many things will be available. So some data are very easy to collect. And another point is, in many places there will be something called the statistical department. Every country will have a statistical department, and they collect so many information. For example, how many buses will move in a city, how many vehicles are brought into a city, or how many riders will be there in a city, etc. etc. They will have all sort of information. Do you remember in Corona time, someone was publishing all the information, right? And these things are published by the statistical departments. And another thing is the data which will be completely new. Now, suppose you're doing one personalized experiment, and in this case, what you do is you have to collect the information by yourself. So, once more, I'll put it like this: data collection is the first thing in doing statistics, and sometimes data is easily available, and sometimes you can obtain it from the government statistical departments, and sometimes you have to collect the data by yourself. Okay, now once you collect this information, the second thing is data processing. Look at this, I'll show you one data. Okay, look at this. These are the weights of 100 randomly picked apples. It is in gram. I went to a nearby shop and measured approximately 100 apples, and one was like 134 gram, another was 136 gram, 142 gram, 139 gram, etc., etc., etc. So look at this. I have 100 pieces of information, and by looking at all these numbers, to be honest, I'm not able to figure out anything. Now, let's go for real life scenario. Sometimes when people collect data, they will collect 1 million pieces of information. It's very easy now because you can do collect data from applications. You can collect because nowadays it's a little bit easy to collect data. You can collect data using mobile applications, using websites, and you'll get a lot of data, maybe 1 million, maybe 2 million pieces of data. Now the question comes, what will you do with all these numbers? You're not going to get any idea by looking at all these numbers. So point number one, we have to reduce this information into a few useful numbers, and these numbers are called statistical measures. And for a simple analysis, the measures that we use are called central tendency and dispersion. And don't get worried by seeing all these words. These are something which you have already learned. Central tendency is something like mean, median, mode, geometric mean, harmonic mean, etc., etc. Basically, they are called the averages. And dispersion means how dispersed is the data from where to where. Look at this. By looking at all these numbers, I'm able to understand the apple will be between some gram to some gram. So that gives me a range. I'm confident that an apple will never be smaller than this or bigger than this. And that is what we discuss when we learn about dispersion. So whenever we have a minor analysis, we are interested in two things. One is called central tendency and another is called dispersion. Now look at this. For example's sake, I have not calculated. I don't know also. If you want, you can calculate. Let's say the average of all these numbers is 142 gram. Now look. Instead of looking at all these numbers, I can understand that in an average, if I buy an apple from that particular person or from that particular tree or whatever, or that particular variety, I should expect my apple to be somewhere nearby 142 gram. But that information is not complete. Now I'm looking for more clarity. And let's say I got the dispersion, let's say standard deviation or the mean deviation to be 10 gram. Oh, now things are like really, really clear. If I take one apple from this particular variety, I should expect that the apple weight will be somewhere around 142 gram. And this tells me most of the apples will be between 142 minus 10 and 142 plus 10 gram. That is, it will be somewhere between 132 gram and 152 gram. Did you get the point? So this is all about central tendency and dispersion. Now look at this. There are many measures of central tendency, and all the measures work with different logic. For example, if you want to calculate the arithmetic mean, then you'll add all the data items and divide by the total number. If you want to calculate the median, then what you do is you arrange all the numbers, you'll arrange the numbers in ascending order and choose the one in the middle. That means you're dividing the data into two equal parts. And mode. Mode means the most repeated value. What do you mean by mode? The most repeated value. By the way, in garment industry, in ready-made industry, mode is very important. If you think like a shopkeeper, you'll be able to understand why. Come on, what sort of commodities will a shopkeeper keep? Will he or she keep something which people ask very rarely or which people ask frequently? So this is very important in designing the size of the ready-made garments, the shoes, the belt, etc. Because theoretically, you learn later when we learn normal distribution, approximately 70% people will be focused. Approximately 70% people can be targeted if you use the concept of mode. I'll give you one example. Suppose the mode of shoe size. Look at this. The shoe size. Let's imagine the shoe size which are available is normally between 32 and 44 for grown-ups. So the normal shoe size for grown-ups is between 32 and 44. And one shopkeeper knows that the most repeated value by the customer is somewhere like 37. Now what he does is, he will use this average value. The mode is of course an average value. Then he will calculate the standard deviation, and let's assume the standard deviation is 3. Now he is able to understand maximum number of customers will be demanding the shoe size between 37 plus 3, 40, and 37 minus 3, 34. So that particular shopkeeper will keep maximum shoes which has size between 34 and 40. So once more I'll repeat. Statistics starts with data, and data will be analyzed. And once we analyze the data, we will be able to get some information about the particular scenario. And then we use that information for implementation purpose. Anyway, we learned that we can obtain data through different methods. Some are very easy, some are a little bit difficult, some are extremely difficult. And the problem starts because we are not able to understand anything from the data values. When you have 1 million numbers or maybe 1000 numbers, you will not be able to understand anything from those numbers. So we want some sensible numbers which can talk about the data. And those numbers are called statistical measures. And in a very basic analysis, we are interested in two things. One is the central tendency and the second one is deviation or dispersion. And the mainly used measures of central tendency are arithmetic mean, median, and mode. And everything runs with its own logic. And once more, let me repeat, you can use a calculator to find all these things. And in the next video, we will learn how to use a calculator and find these things very easily. Okay, now dispersion. The most commonly used dispersion measures start from range. Range means we will get a rough idea what is the highest value and what's the lowest value. You find the difference, you'll be able to understand the range. And some dispersion measures are a little bit complicated, like standard deviation, and this is one of the most trusted measurement for deviation, and interquartile range, etc, etc, etc. Anyway, I'll be back with another video very soon, and in the next video you will have to use a calculator, so please be ready with your calculator. So till then, my friends, bye.